All right, so let's get started. Welcome everybody to our joint webinar here with CircleCI and Pulumi. My name is Jason Souza. I'm one of the customer success engineers here at CircleCI. Along with me here on the webinar is Chris Smith. He's the software engineer for Pulumi. And today we're going to be discussing supercharging the CD and CI/CD. So mostly talking about reusable CI/CD components with CircleCI Orbs for Pulumi. And before we get started, I just wanted to let you know that this webinar is being recorded in Zoom. So as we're going along with this presentation, if you have any questions, please click down below in the Q&A portion of this Zoom call. At the end of the presentation, we're going to spend the time allotted towards the end to answer any questions that you may have during the presentation. And also, if you feel like you have maybe missed a slide or two as we go along, do not worry, this is recorded and will later be published in YouTube for all of you to see. So without further ado, Chris, take us away.
All right. Well, hello. My name is Chris Smith. I'm an engineer at Pulumi. And as you'll find out very shortly, we are very excited to change the way that people develop cloud-native applications. So there's a lot of text here. I'll just let you take a moment to read the slide. Since you're attending a webinar from a CI/CD company, I can assume that you probably know the benefits of having a strong CI/CD pipeline to continuously build, test, and hopefully deploy your software. And so today we're going to drill into that second piece, the continuous delivery aspect. And that is the practice of configuring, say, CircleCI to automatically update your staging or production environment on every code commit. Now, this is in practice pretty hard just because not only do you need to set up the machine state with all the right SDKs and libraries, but also you need to manage the accounts and credentials, and it can be just burdensome for a lot of applications. And so I'd like to introduce a new product called Pulumi that can dramatically simplify all of that, as well as, when combined with CircleCI Orbs, make continuous delivery not only simple and approachable, but allow you to be more productive in the end. So to achieve that, we're going to have 3 steps in our talk today. First, we're going to review the challenges of continuous delivery, introduce Pulumi, and then supercharge continuous delivery using Pulumi and CircleCI Orbs. As you can tell, supercharged is definitely the goal, hence the lightning bolt and emojis. Very serious. So to start with the challenges inherent in continuous delivery, I need to define what that means, right? It's a very broad term and kind of nebulous. So I'll start with a totally made up and barely accurate history of the world in terms of continuous delivery and what this means for developers. So at the dawn of time, the only way to update software was using a single web interface. And it offered unlimited power for developers and administrators alike, but was just kind of overwhelmingly complex in the number of knobs it had. And so mankind, who at the time was living in caves and whatnot, developed bash scripts to roll out infrastructure updates. These bash scripts then turned on their masters, devouring them alive, and ultimately took over the land, and there was much pain and sorrow. So the takeaway here is that when you need to make updates to infrastructure, right, if it's manual, it can become tedious and error prone. And so any sort of CD solution needs to not only be safe, but also reproducible. Because if, let's say, something does go awry and you need to roll back to a previous state of, say, your configuration, unless you have a good notion of history or previous update versions, that can be real problematic. Now, once people had used these bash scripts, they were looking for a better way. And so great inventors came across the noble and beloved JSON and YAML and started defining their infrastructure in terms of these languages. Now, that was great and fine and wonderful, but over time they were perverted into grotesque abominations. So I don't want to single out any particular tool used by Kubernetes, but let's just say that somebody thought it was a good idea to start with a text processing language that generated JSON, which then was taken as the input into another system, right? And so when you go down this path, you end up with lol, I have no idea what this is as the input, and lol, I have no idea what this is, but I guess it's okay as the output. And so the problem is that when you're using custom domain-specific languages or just what I would claim as grotesque configuration languages, it's difficult to not only maintain, but also capture the important interdependency of various cloud resources. And so what we want is a tool that can capture that complexity, but of the complexity of like the desired state we want, but without resorting to one-off languages that don't have any tool support or are difficult to understand and so on. And then finally we came about super ultra complicated tooling for doing continuous delivery, right? And tooling isn't itself the problem. In fact, I've spent my entire career developing tools for developers. I'm a huge fan. But the problem is that in the continuous delivery space, unless you address the core problems with that complexity, you're just layering tools on top of tools, which becomes even more difficult to maintain, especially when things go wrong and you need to pick through all of those layers of dependencies to understand what exactly went wrong and how to fix it. And from the context of doing this continuously, we need some sort of tool or process that integrates well and nicely with our existing continuous integration pipeline or solution, right? Even if we had a tool for deploying our software that we really liked, unless it's part of that continuous integration pipeline that, say, runs every time you commit code, then it's just another set of tools and infrastructure to maintain and support. Okay, so I just got done complaining about the inherent difficulty in continuous delivery, and I've highlighted 3 challenges that some, hopefully, great tool would support. Right? Capturing the complexity of defining kind of resource state, being able to apply changes safely and reliably, and then finally integrating into your existing CI/CD solution. So as you can probably assume, I'm going to introduce something called Pulumi, and it's going to solve all of these problems, which, of course it does, right? So what is Pulumi? In a nutshell, it's this. If you look at the right side of the slide, you'll see some code, okay? That code is a JavaScript program that'll run on the Node.js runtime, and that defines a set of cloud resources. And particularly, it sets up an EC2 security group and then starts a new VM on AWS, okay? This code makes up a Pulumi program, and when you run that program, Pulumi will create any resources that don't already exist. And say the next time you run that program, it will update any resources that need to be changed, delete resources that are no longer referenced, and so on. So the key thing to note here is that unlike other approaches, Pulumi doesn't resort to some new configuration language or try to define something in XML or YAML or what have you. Pulumi uses real code, and so you can define your infrastructure in that code. So whether you want to use Python, JavaScript, Go, or C#, Pulumi allows you to sidestep all the complexity of managing SDKs, bash scripts, and one-off tools, and you can just write code in your favorite language, run it, and then Pulumi will take care of all the cloud resource management. So this is real code for real cloud infrastructure. And so by using a real programming language, there are a lot of benefits that come out of that. Of course, productivity. You can use your existing tools and IDEs, code linters, but that also extends to, say, getting syntax errors from the compiler when you introduce some sort of problem. Or let's say you create some cloud component, let's say it's some complex networking rules that you want to apply to all the deployments in your company. Well, you can have unit tests for that code and run those just like you would the code or tests for, say, your business logic, right? And the other set of code that's going to be running on the cloud. Also, and perhaps more importantly, is that Pulumi can fit within your existing CI/CD pipeline. Pulumi, by managing your cloud resources starting with code, right, you don't need to have build test handled by one system and then package deploy, go to some other system, and then actually do the deployment elsewhere. With Pulumi, you can take your existing CI/CD pipeline from build and test to build and test and deploy, because your CI/CD system already has all the language tools and whatnot to actually build and run your application. So naturally, we could spend a lot of time talking about policy and resource state and management, but I'm going to gloss over that for this talk, and we'll have time for Q&A later to go over the specifics. What I want to do is continue to drill down into continuous delivery and how Pulumi can simplify that. So the scenario we'd like to enable here, and what we'll be working towards, is can be seen in these screenshots. We want to start with defining a code change that is something that we want to make some update or tweak to our cloud infrastructure, and just use a, say, GitHub pull request for that. Not some sort of manual review that some high priest needs to make manually across like the AWS console, but it's just a code that you can look at and review like any other. By using our existing CI/CD pipeline, we can preview those changes and then get the results surfaced back on that pull request. So in that middle image, you can see a comment on a GitHub pull request that is, this was the change that is being made. And then finally, by using Pulumi, we can safely apply those changes. And if the need arises, take care of like the rollback or version management, the history tracking of resource changes, and so on. So that's the goal. Let's finally step into it, right? Let's figure out how to supercharge our continuous delivery with Pulumi and CircleCI Orbs. Of course, we can't really deploy anything unless we have a slick demo app. So for that, I'd like to introduce Browser Hack. You may be familiar with the classic 80s computer game NetHack, which has been ported to perhaps every conceivable computation platform on Earth. And the web is no different. So I actually can't take credit for the porting work. That was done by a gentleman named Lou Wang. But what I've done is taken his work to compile NetHack which is originally like C source code, compile it to JavaScript, and then run it in the browser. And so what I've done is written a small Pulumi program to define the cloud resources to then serve that website. And so it's using AWS CloudFront, which is backed by S3 and has the domain name, and so on and so forth. So if you go to browserhack.longnorms.net, you will see like, yes, it is NetHack in the browser. And so we'll just be in a random elf, there's backstory. Hey, it's NetHack. If you've ever played NetHack, you may feel right at home. Okay, so this is our app, and the code is written in Pulumi that will allow us a way to describe the cloud resources and more easily deploy that to the cloud using code reuse of like existing cloud components and whatnot. And so what we'd like to do is then set up our CI/CD pipeline to automatically deploy this program, say every time we push to our GitHub repository. And so that's the part where CircleCI comes in. Now, I assume that since you're at a CircleCI webinar, you're probably familiar with integrating CircleCI or using it today. So I'll just gloss over that. The thing that we do want to spend time on is a new feature of CircleCI called Orbs that allow you to compose and reuse packages. And so for that, I'm going to hand it over to Jason to go into more detail.
All right, thanks, Chris. As Chris mentioned, we're here to basically discuss Orbs and specifically Pulumi Orbs. But before we can get into that, let's actually learn a little bit about what Orbs actually is. So Orbs is pretty much just a package set of CircleCI config that you can reuse and share with projects within your organization. So an Orb is going to have some predefined commands, executors, and jobs in which you can reference in your CircleCI configuration to perform any work or integration that particular Orb can provide. So Orbs will pretty much keep your configuration a lot cleaner and keep all of those things up to date. And up to the date of this recording, as of the date of this recording, I should say, CircleCI right now is the only CI/CD provider that comes with that offers pre-packaged configurations. Also, additional use cases in which you can use Orb for right now are in the subject of CD. If you can standardize your deployment process by packaging up the configurations and the process specific to your deployment process in the actual Orb. This also, you can also use Orbs to streamline the CI/CD process by integrating with tools such as Pulumi. And the way that works is, and the way Orbs are comprised in is pretty much in three different components. Commands, executors, and jobs. So for commands, they are parameterized sets of steps that can be invoked as a step in a job. So for this particular example, we have a say hello command that we're going to create, set a few parameters in which you can set the necessary environment variables in, and then set the as many steps as you needed to perform that particular command or to run that particular command. Executors basically just lets the Orb know which environment to run in, and the jobs portion is similar to the CircleCI jobs that you're familiar with. And here, then you can call for the name of the particular job, hello build, and set the executor, in this case, to default, which we have set up above, and to run the step hello, say hello. So this is just a quick overview on how Orbs are structured, and Chris here will now show you how you can use how now you can invoke this with the Pulumi Orb. So, Chris?
Thanks, Jason. And I really want to underscore how powerful of a concept this is, the CircleCI Orbs. Right? One of the benefits of Pulumi and using code for defining and managing infrastructure is that you can reuse common components that, say, are maintained elsewhere, or that you can then standardize across a team or organization. So for example, you don't need to say write some custom one-off package for like Memcache or a Redis service. Instead, you can just go to npm or NuGet or whatever package manager you want to use and get the existing Pulumi code that you can reuse. Same way that CircleCI provides that same capability, except rather than for, say, code and cloud infrastructure, you're reusing and composing packages for configuration, jobs, or executors. So if you look at our CircleCI configuration here, this is the most basic system you can have for, say, updating a Pulumi stack. First, we reference the Pulumi Orbs package. We then go into the steps for our CI/CD job. We log in to Pulumi. That orb downloads the Pulumi command line tool and then authenticates with the Pulumi service. We then build, install the npm packages, build, and then run the tests. And then we run, Pulumi update to actually deploy our cloud infrastructure. And that's it, right? You don't need to worry about what version of the CLI you're getting. If you want to specify a specific version, you can set the parameter on the orb. But a lot of these details are then packaged up in these orbs so that you don't need to worry about them. You can just reuse the existing packages that are maintained elsewhere. So this is the most basic configuration, but you'll notice if you look very carefully that there's quite something that isn't quite right. So what we want to do isn't just deploy one stack or set of resources on every push. That's not like following the best practices for DevOps, right? What we want to do is have multiple environments that we can then have a staging environment that maybe is updated much more regularly, and a production environment that is only updated after we've done more testing, more validation. Maybe we want to get some manual review process, whatever. So both CircleCI and Pulumi support setting up these multiple environments seamlessly. So Pulumi organizes resources into things called stacks. A stack is a way to run the same Pulumi program that, say, stands up your browserhack.net program, except it's parameterized so that you can have, say, a staging environment or a production environment, or even if you're an individual developer on the team, your own kind of dev version. So if you go to bhstaging.longnomes.net, you'll see the staging environment of the browser hack app. And the way CircleCI can provide this easily is just defining different workflows. Before we just defined a single CI/CD or CircleCI job that then deployed a stack. But if you want to have, customize how, say, the deployment rollout happens, or, how you want to handle pull requests or whatnot, you would just define different workflows and then use a branch filter to determine which, workflow you wanted to run based on where the code was going. So with the job defined here, we update the staging environment after every commit to master. But we only update production when changes get made to the production branch on GitHub. It's simple and works. But the thing I'd like to draw your attention to is the preview changes workflow. So it runs on any branch except master or production. And what that does is it's used for the standard pull request GitHub flow. Whenever there's a change that isn't a commit to master production, we don't want to update our cloud infrastructure. We just want to preview those changes to know what would happen if we were to merge those changes. So to show you what this preview versus update means most succinctly, take a look at this image. A preview just shows you the changes that would take place if you were to run the Pulumi program. And this is ideal for a pull request type model where you propose some code changes that are defined in code and then the Pulumi GitHub app will then comment on that pull request to show you the changes that would be made. So I'll just navigate to the pull request mentioned in that slide, and it's right here. So earlier I had browser hack -staging.lawnmows.net, and that was pretty long, so I wanted to shorten it. So I just made a change to a configuration file for the staging environment, and then created the pull request. And CircleCI then ran the preview changes job, and then as soon as the updates were processed by Pulumi, the Pulumi GitHub app left a comment here explaining the changes. So we can drill into the CircleCI workflow page to see the various steps. And you can see here's where we use the Pulumi Orb for previewing the changes. And then the update can also be seen on the Pulumi service. And so we can see, for this change, we deleted the CDN, or excuse me, the DNS record, and then created, the new bhack staging. And so this is the ideal flow that we want to achieve with, our supercharged CI/CD, right? We're just proposing changes, integrating them. We get input on whether or not the change is safe or potentially destabilizing, and then we can just merge that pull request and then have confidence that it automatically gets rolled out. And so this is taking a step towards that more robust CI/CD kind of world. But there's another problem that in practice you'll probably run into, and that is concurrency control. So this is something that we kind of learned the hard way at Pulumi. We dog food our own product and also have our own kind of staging and production environment of our service. And we had configured our CI/CD pipeline to update the staging environment on every push. Now, an important and critical feature that Pulumi has is that we prevent you from making concurrent updates to your cloud resources, because it's far too easy to corrupt your resource state in doing so. But if you are practicing continuous delivery and you have a high volume number of changes going into, say, a repo, then the problem is that many of those Pulumi updates will fail because it'll just be blocked. It'll say an update is already in progress. So there are several ways that you could add encode policies to, say, queue up those updates or skip updates and whatnot. But unless you're really excited about writing the configuration for that, you could just use an existing CircleCI orb. In fact, somebody on the Pulumi community Slack, recently asked the same question and brought the EddieWeb Q orb to my attention, and it does exactly what you'd think. When you're running, CircleCI jobs, you can run, jobs in parallel. There's no problem. But if you are updating a Pulumi stack, you want to ensure that only one update to that stack can happen at a time. And so you can use the, until front of line orb to wait until just that happens. Of course, if you want a more sophisticated policy, you can look on the CircleCI orb registry for one, or like Jason said earlier, you can just create your own. The point is that you're not adding all that additional logic and complexity to your config file, because ideally you just want your CircleCI config to describe how to deploy your applications, the thing you care about. How the mechanics of queuing or doing the concurrency control can be left up to the orb itself. All right, so we've covered a lot of ground, introduced a lot of concepts. Let's try to take a step back and recap, okay? So how do you supercharge your continuous delivery? First, let's review some of the problems that are inherent in this space. safely and reliably reproducing changes, capturing the complexity of a desired resource state, and then having tooling that integrates into our existing CI/CD pipeline. Pulumi allows you to define your infrastructure in code, and it seamlessly fits within your existing CI pipeline. It's not some other tool instead of SDKs and whatnot. You can use the code like you're used to, IDEs, linears, the whole shebang, and then reuse and compose those code packages to be even more productive. CircleCI provides a powerful and flexible workflow system to perform those updates and deployments, and has deep integrations into GitHub and Pulumi. And via its Orbs offering, can reuse and compose these packages so you can be even more productive. So I'm gonna hand it off to Jason to talk about some of the resources available if you're interested in learning more about Orbs.
Yes, thanks, Chris. So yeah, here's just a list of some links that may be useful for you to help you get started and learning a little bit more about Orbs, and even diving in and to creating and using your own Orbs. So this should have all the information needed for you to help you get started and learn on ways to start implementing your Orbs into your own configuration. And there's also links here for any relative so also links here for the Orbs registry, and also all GitHub repos in which we publish these Orbs in. And Chris, if you don't mind going to the next slide. And if there's anybody in the webinar right now who is interested in becoming a partner, we do have several partners right now that's in the DevOps space, the monitoring space, security space. So if any of you are in here that are interested, please feel free to contact us, and we'd be happy to help you get started in creating your first Orb with CircleCI.
Well, thank you very much for your time. We have a little bit of time left for a Q&A. So if you would, there's a Q&A section on the Zoom meeting, and so just feel free to ask away. I'll look at the questions that have been open so far and have a crack at them. So the first question is TypeScript supported? And the answer is yes, right? Pulumi, is designed in such a way to work with any programming language, and TypeScript and JavaScript are definitely well supported. In fact, probably most of our examples are available today are written in TypeScript. But that having been said, we're expanding our support for Python and Go, and somebody from the greater Pulumi community is working on a C# version of the language. In fact, there's also an F# variant as well. So the next question is, what's the role of the Pulumi service, and why do I have to log in? Having a central service involved in updating my infrastructure makes me a bit worried. And that's a very good point. It's something that we hear a lot of on the team. So the role of the Pulumi service is to essentially just manage that global lock for your resources, so that no updates can happen concurrently. But we also provide things like resource history, so that you can go through the previous versions, know when a resource was created, what pull request or commit made that change, as well as things like that GitHub app for commenting on pull requests and things. So that's part of the value that the service provides. But we are very aware of the concerns of just having this external dependency. So the short answer is it's something we're looking at. We do offer an enterprise version that can be on premises, so that you can kind of manage the Pulumi service on your own. but there are also other options available. And so you can use Pulumi in a mode such that it'll work on a local machine without requiring a web backend. What languages does Pulumi currently support? I think we already covered that. Can you describe a general rollback procedure for using Pulumi? So the kind of background for this question, if you're unaware, is if you've made some problematic change to your code, and so you're having a problem in your live site, you want to go back to the last known version of that resource configuration or structure. So the way that this works in Pulumi today is just a matter of git pushing the previous commit of that code, right? Which would then trigger your build and deploy pipeline to run the Pulumi program with that previous kind of state, and then Pulumi would update your resources to match that earlier version of the state. So today it's that's the simplest way to achieve that. Although what we're working on now is thinking about ways that we could do this like either safely from within the Pulumi UI. For example, like clicking a button to do that rollback without needing to do any git pushes. Alternatively, being ways to set up a workflow that would require like manual approvals or running some automated testing and before the update would be considered complete and continue rolling out. So it's kind of involved, but that's the short answer for now. How do you recommend using managed credentials and secrets with CircleCI and Pulumi deployments?
Yeah, of course, I can actually answer this question if you don't mind.
Yep.
So we actually recommend that you use CircleCI context. So context is a feature that it pretty much provides a mechanism for securing and sharing environment variables across projects. So if you can actually set this up on your CircleCI settings page, and under context, you can create a particular, I guess you could say, a set similar to how Orbs, how you can, as we were talking on Orbs, how we can create, a prepackaged CircleCI commands and whatnot. Context and similar, where you can package up environment variables to be used and shared across all projects. And if you have any more questions regarding that, I can send out some additional literature on helping you get set up with using context for your environment variables.
Just to add on to that, the passing secrets and things like AWS credentials to Pulumi is something that needs to be done kind of carefully, so that, say, you don't give us or let us even see any information that we shouldn't. So you never need to pass your AWS credentials to Pulumi. They just need to be available in the environment that is running the Pulumi program. So like Jason said, as long as the CircleCI executor has the AWS credentials available in a file or in an environment variable, then Pulumi will be able to apply that update. But you don't need to, say, store that or associate those credentials with your Pulumi stack in any way. We also provide a way for you to save configuration secrets with the Pulumi service. And so they're encrypted, and you need to have certain permissions in order to decrypt those. But that's kind of a separate feature with different trade-offs. So moving along, how is blue-green handled? Specifically, I want to be sure that there will be no outages after running Pulumi update to GCP GKE infrastructure. So I have two answers for this. Right? The first answer is, at the most basic level, Pulumi is kind of taking some desired cloud resource state and then making the changes necessary to kind of achieve that, updating resources, deleting them, and so on. So there's nothing specific to Pulumi that would prevent or cause like an outage. It's entirely based on how that the resource changes are defined in the Pulumi program and how they're rolled out. So it's possible to construct an update in such a way that it would cause an outage. So in terms of AWS, you would just say, tear down the EC2 VM, stand up a new one. But a more safe approach would be to set up the auto scaling groups and whatnot to safely transfer traffic and whatnot. And so the second answer to this problem is that's something that we want to put into like the Pulumi libraries and packages that you can then kind of pull in and reuse when relying on Pulumi. Right. So we have a set of GCP and GKE packages for, say, standing up resources. And I don't know off the top of my head if there's a set of like a veneer on top of that that would allow you to safely do updates or failovers and whatnot. But that's how that sort of thing would be applied. And I guess another way to kind of know if you have an outage or whatnot is just standing up a staging environment and having like monitoring and alerting and probers just like you would your production environment. And that way, since it's the same code, the same program, it's very easy to replicate your entire dev stack. And so, just in the process of, updates going through various environments, you would definitely know if something caused problems. And so I think we have time for just 2 more questions. But again, if you have any other questions, feel free to email me. There's a Pulumi community Slack, and so on. So where do we store state? So the Pulumi stores its state in one of 2 places. So if you're using the Pulumi service, it's stored in our data store. And so, if you move to a different machine or whatnot, like all of your cloud resources are just always available via our service. If you don't want to use the Pulumi service, it's possible for you to store your application's resource state on your machine. The kind of caveat there is then if, say, your machine gets hit by a meteor or your hard drive dies or something, then you lose track of like what resources were associated with that stack and so on. And so, it would be safer to say back that up to S3 and kind of have some better management around that. But that's the short answer. And then the final question here is, what kind of resources are supported? GKE, EKS, General Kubernetes, GoPass? Are there plugins or providers similar like Terraform? The answer is yes, all of the above. There are, it's possible to write, Pulumi custom resource providers for Pulumi, and we also can take advantage of the existing ecosystem of resource providers in the Terraform space. And so there's support for AWS, GCP, Azure, right? All the major players, as well as if you wanted to define something new or custom on your own, it's very straightforward. But again, if you want more information, pulumi.io, or just start asking away on the Pulumi community Slack. I am Chris on that. Yeah. All right. Well, I think that's all the time we have. Thank you very much for attending. And Jason, is there any closing thoughts you wanted to add?
No, I think you've closed it off pretty well. So thank you again, Chris, for joining us on this webinar and showing us Pulumi.
Thanks. Have a good day, everyone.